While drilling wells and after drilling wells, it's very important to have barriers. You need to have barriers, secondary barriers, while drilling the wells, barriers like the blowout preventer system. And you also need to have barriers after drilling the well, barriers like the Christmas tree. So, in today's video, we'll be looking at these barriers, we'll be looking at this piece of equipment that provide these barriers. And those are the equipments that we will be discussing in this section of fundamentals of subsea drilling operations. So, as we move into this topic, do not forget to subscribe and click on the notification button so that you can always get the updates that we make on this channel. So, the equipment we'll be discussing today include the Christmas tree. We'll be talking about the debris cap that's used to cap the Christmas tree after drilling the well. We're talking about subsea tieback assemblies, and we're looking at the blowout preventers. There are different components of the blowout preventers, like the rams, the annular, the choke and kill lines, the control pods, and the accumulators. We'll be looking at all these equipments as we discuss. So, moving straight into the conversation, the first equipment we'll be looking at the Christmas tree. Now, it's of similar concept to the surface Christmas trees. What do they do? Provide containment for these wells after they've been drilled and completed. So, this is what the Christmas tree looks like, and it provides that ceiling on the wellhead and control while producing the wells. For the subsea operations, it is usually very sophisticated for obvious reasons. These Christmas trees for subsea operations sit on the seabed, so it is very important that you have controls from the seabed all the way to surface, so that you can manipulate and control these wellheads as required. So, looking quickly to the right, sorry, to the left, this is what the subsea Christmas tree looks like. This clearly here is a vertical Christmas tree, because I can see an annular swap valve here, and this is the production swap valve. You have your crossover valves somewhere. You have your crossover valves somewhere here. Then you have your pressure, sorry, your production wing valves here, the production master valve here, and tree cap test. I mean, all these valves have functions, and with these functions are pretty much controlled. Most of them are pretty much controlled on surface. So you see how sophisticated it can look. I mean, looking at the size alone compared to that of a human standing very close to it, unlike that of a surface tree, which is very not as large as this and can be manipulated on surface. To the right here is a horizontal tree. So this is a vertical tree and this is a horizontal tree. The one of the main differences between these two trees is the availability of the annular swap valve on the vertical tree. Here, this is the vertical tree. I mean, about the same. It's pretty much about the same system with the horizontal with the vertical tree. The difference is a mode of installation. For a horizontal tree, after you land your lower completions, you have to um put in a barrier, like a breach plug, put in a or on RTTS, put in a barrier, recover the BOP. After the BOP is recovered, you land the horizontal tree. Then the upper completions is run and landed in the horizontal tree. So the sequence is pretty much you put in the after landing the horizontal completion, you pull the BOPs, you set in plugs for as a barrier, pull the BOPs, then you run the Christmas tree, then run the BOP on the Christmas tree to provide the barrier while you are running the upper completions. Then you run the upper completions and land it in the Christmas tree. So pretty much the tubing hanger profile is in the Christmas tree. So you land it on it. For a horizontal for a vertical tree, it's the reverse. So you once you are done, you have to land your completions, then you run the Christmas tree to land on the completions that you've installed. So it's completely different. Then the next piece of equipment that we'll be looking at the debris cap. The debris cap is a non-pressure device landed on top of the suspended wellhead. So permit me to go back to the last slide that we just passed. So this looking up here, this is pretty much where the debris cap will be installed. So it's just installed to cap the well after you're done. You're done. you're done completing it. So it should have a robust design provided to provide the mechanical protection for the wellhead, and it should be able to isolate debris and prevent debris from accumulating in that area. Because sometime in the well, you might want to come and retrieve that debris cap to re-enter the well. You want to be able to come there and the area is void of debris. So this is what the debris cap looks like. It should also have it should also be designed in a manner that prevents fishing nets and other equipment from snagging onto it and perhaps destroying that debris cap, because you want that seal at that cover on your high pressure wellhead housing on the Christmas tree to remain intact. So the next piece of equipment we'll be looking at the subsea tieback assembly. Now, sometimes when developing a field, you might not have some fields that you might want to develop with the tension leg platforms or the spar. You At the moment you want to develop that field subsea style, then when you have this equipment, I mean these facilities fully constructed, you now get them to location, then tie them back to surface. So in this case, that is what the subsea tieback assembly does. So the wells are drilled and completed subsea style before the equipment come, and once the equipment come, we now tie back the well from subsea to surface. So that's pretty much what this assembly is for. So like I said, that's what the tieback assembly looks like, and this is where we use it. So what I just said is at the bottom here, you've drilled the wells, they are completed subsea style. Then once these facilities are fully constructed, ready to go, you bring them on location. Then you tie back these wells from subsea all the way to surface. So that is what these systems are used for. Then the next piece of equipment is very important and very popular piece of equipment. Even those who are not petroleum engineers, they always hear of the BOP, courtesy of the Macondo. I mean, when they all hear how the BOP field. So this is a very important piece of equipment. So it acts as equipment for secondary well control. Like we all know, the primary well control system is your drilling fluid that's required to provide that overbalance over the over the formation pressure. um, it consists of annular and ram preventers, and there's pretty much similarity in functionality between the subsea and surface stacks meant to seal off the well if there's an influx or if there's a kick. That's what surface BOPs do, and that is also what subsea BOPs do. Now, subsea BOPs are more complex because they are run and they are installed on the seabed. I mean, think of it, for the surface BOP, any issues we have can be rectified on surface. But for subsea BOPs, it has to be run down on bottom. You can't access it easily. So a lot of redundancy needs to be built in. Final comment here, it is painted usually white or yellow so that the remote operated vehicle that either goes to function on any of the valves or is there to provide give you the, I mean, be the eyes during that operation, perhaps when latching and when retrieving, you can see it quickly if it's yellow or it's white. So this is what the subsea BOP looks like, ladies and gentlemen. You can see the size of this BOP in and compared with that of the size of a human being here. So this is what the BOP looks like. Up here, you have your flex joint. That's the riser joint on top of your lower marine riser package. So the flex joint that provides the flexibility that the riser doesn't remain so rigid that can break off. So you have your LMRP up all the way here, and just in case you need to unlatch, you just unlatch from here. So you closing the well here, you can unlatch from here, then move away. So that's the annular preventer for the lower marine riser package. You have your choke and kill lines here. You have your flex joint. So you have your annular preventer of them for the main BOP system. So you can close in the well with this annular preventer right here. Then there is another annular preventer up here, so you can close in the well here, then unlatch and move away. You have your accumulator bottles. I'll be speaking about that. For the surface BOP system, the accumulator bottles are usually on surface, and once you close, the hydraulic fluid goes to the system, to whatever you want to close or whatever you want to unlatch, and it quickly functions it and does that. But for The subsea BOP systems, because of the distance that the fluid has to travel, what we do is that we have also have accumulator bottles installed on the BOP. You have some on surface that you use to recharge, but because of distance, the accumulator bottles sit through the BOP on bottom, so that when you function, it quickly at the required time as per API that you need to function whatever system, be it the Annular, be it the RAM system, it communicates to it immediately and it shuts in. So you have your RAMs here, you have your accumulator bottles here, you have your guide posts for alignment, and you have your wellhead connector that latches onto the BOP. So that's the BOP system. So the next equipment we'll be looking at the lower marine riser package. I already spoke a bit about it on the initial slide. So looking at this system here, this is your full BOP system. What you have here is your lower marine riser package. I'll just highlight it out quickly. That's your lower marine riser package with with the control pods. You have your riser there sticking somewhere up here. Then you have your flex joint that provides flexibility for the system, and you have your lower BOP system down here. So you can be latched on the wellhead system, and for some reason, maybe you want to move away because of adverse weather, you can close in the well, then unlatch and get away with your riser, and the lower mine riser package can take everything away and get rig off location. So this is what the lower mine riser package does. So just to read out a little bit of some of the points we have here: it's mounted on the BOP. It carries other items like it carries the second annular preventer, like I mentioned, and that riser adapter provides connection for your choke and kill lines. Then at the center, you have your flex joint that allows 10-degree and angular movement from side to side. I spoke about that. Then the angle at this joint is monitored, and we make sure that isn't exceeded. So pretty much what I discussed looking at this equipment. So I just threw this on to show how we how it is pretty much looked at. Here in green is acceptable region of failure, but once the inclination increases and gets to this point, it is unacceptable. And at this point, we might have to unlatch the LMRP and move away so that we don't snap anything or inadvertently damage the wellhead system. So, parts of the BOP system, we have the RAM preventers. To here, a few of them that we have the fixed, we have the variable, we have the blind, and we have the share. Some subsea BOP systems come, the blind and share come as one as blind share RAMs. So the fixed, as the name implies, has a fixed OD and covers. So when you close it, when you close it, it covers the pipe that has that fixed OD. For example, a 5 inch pipe or a 5 inch fixed ram should cover a 5 inch pipe or close onto a 5 inch pipe. A 5.5 inch fixed ram should close in a 5.5 inch pipe. You can't use a 5 inch fixed ram for a 5.5 inch because that's not the size. If you want to do that, that takes us to the next type of RAM. That's the variable RAM. So the variable RAM covers a range. So you might decide to get a variable RAM that covers 5 inch or 5.5 inch all the way to 278. So what it means is that you can close onto pipes from 5.5 inch all the way to 278. So if you have a 3.5 inch in the well, so it's telling you that it can cover, it can also close onto it. If you have a 5 inch, 5.5 inch in the well, it will close onto it. However, if you have a 7 inch, it won't because it doesn't fall within that specified range. Then the next RAB type is the blind shear arm. So clearly you can see um, a piece here. That piece here is called it's actually what shears the pipe. It cuts the pipe. So it's different from these other guys. These other guys seal onto the pipes and provides sealability and prevents fluid from coming from the bottom. This guy shears the pipe, as in cuts the pipe and seals. So for drill engineers, we see this as kind of our last line of defense. So when all everything has failed and we need to get out of the location, you cut the pipe, seal it off, and might seal that well and decide to unlatch from the LMRP and get away. So with the lower BOP that is on the system, you would have close that share. I mean, perhaps closed with the pipe, and perhaps maybe the pipes failed, and you are still getting influx even with the fixed or variable rams. The next thing to do is activate the blind shear rams to cut off the pipe, seal, and you can now get everybody on the rig, or rather on latch from the wellhead system, and move away. Then perhaps re-strategize, come back on how the well will be re-entered. The next set of next RAM system, sorry, the next BOP component that we'll be talking about are the annular preventers. So the way the annular preventers work, they're like a piece of the main equipment. Here is what you see here is the packer here. It looks like a donut. So because if you look at that profile, the way that thing works is it has, once you put in pressure from the system, it has um equipment that compress the packer system to close on to whatever equipment that is in the well. So it closes on to that equipment and provides the required sealability. So what I speak about is what you can see here right now. So the button is pushed, and once the button is pushed, it passes on fluid here, actuates this system, and when it does that, it pushes it up. And if you notice, once it pushes it up, it slants, and once it slants, it compresses this packing unit, and the packing unit moves this way. So when it moves this way, it seals onto whatever pipe is in the system, providing that sealability and providing influx that's coming from the bottom from coming up to surface. So that's pretty much the way it works. So you can have a couple of them in the system. So you can have, like I spoke on the last, I think, 3 or 4 slides. You have one installed on the lower marine riser package, and you also have one in the main BOP system on bottom. So you can any of them can be used. So pretty much, like I said, one of the main things you should always have in our minds while dealing with subsea systems is redundancy. So here we have Annular. We can sometimes two are installed, one on the LMR, one on the LMRP, and one on the main system for redundancy. So the next piece of equipment we'll be looking at is the yellow and blue pods. They are attached to the BOP system and lowered to the seabed. Now, like I mentioned, for surface systems, the proximity is not so much. You push the buttons, the hydraulic fluid goes to whatever function, whatever you functioned. If it's the rams, it goes in there, pumps and gets behind it, closes the rams. If it's the annular, it goes in behind there, pushes whatever sleeve that needs to be pushed, and the don't the element closes onto the pipe. But for subsea systems, because of the proximity, imagine drilling about 3,000 feet of water, and you have your systems on surface. You need to have your fluid, accumulator fluid, very close on the BOP system, which is what is done. Then you also have accumulator bottles on surface that kind of charge up what you have on bottom. However, having those accumulative bottles on bottom, you need to have a control system that tells the equipment that the BOP system is housing, your annular, your rams, what to do. So these pods are like the control system. So you when you are down there, you have to actually actuate which one you want functional, and it is the one that is functional that will communicate to either the annular or the RAM or whatever system you want to be controlled. However, both of them, like I said, for redundancy, both of them, when you actuate, for example, the blue pod, when you send information gets to two of them. However, one sends the right information to the equipment, and one vents. So vent subsea. On if it was on surface, you actually don't vent. The fluid that is not used goes back to the system. But here we can't afford that, because imagine all the umbilicals will need to send fluid down to the bottom. Then to get it back to surface, you have to build fluid all the way back. You have to build control system, rather a hydraulic system, all the way back to surface. We can't afford that. So the you when you select the actual system that you the actual pod that you want to function, say for example the blue pod, and a button is pushed, perhaps to close the rams or the annular. That pod is what will be communicating to that preventer. So these are the accumulator bottles that will be mounted on the BOP, that um, so that when you pass information to the BOP, you have your fluid quickly, just readily by the BOP, mounted on the BOP, and that information, that fluid, that the pods pass on that information, and quickly that fluid goes to the system that you want functioned. So, like I said, it's mounted close to the BOP, unlike the surface BOP stacks. It's mounted on the LMRP as well, as in for redundancy, and it's charged from the surface accumulators. Charged from the surface accumulators. The next piece of equipment are the choke and kill lines. So the choke and kill lines are lines connected to the preventers actuated. So look at this quickly. Here we are drilling with a pipe in the well, and we have this should either be fixed rams or variable rams. So it's closed on this pipe. We have influx coming all the way here, coming into the well, and from here you can see your from here we can clearly from here we can tell what influx you have in the well. So this is the choke line. It tells you quickly what you have in the well. Then you have another line here that will be used to pump kill fluid into the well. So when it's better to have these lines which are smaller than having the system open and having that influx, which most likely will have some gas, get into your system and unload your riser, because it's going to get past this BOP, get all the way to surface. And as gas creeps up to surface, it expands. I mean, you can check that out quickly with the Boyle's equation. So as it gets in, it creeps up, and as it creeps up, it expands. And when it expands, the possibility is that it unloads your riser, and when you unload your riser, it might become uncontrollable, and you will be in problem. So, but when you're able to um, monitor your well efficiently, and immediately you see that, look, you flow check, you're having influx to surface. I mean, you're no longer circulating, but you're getting returns. That's a positive indication, and immediately you shut that in. And immediately you shut it in, you monitor the well with the choke line, and you can pump your Q fluid in here. Again, we'll be discussing this in detail when we talk about the well control system. And finally, the driller's BOP control system. So this is where all the buttons are pushed, and once we have this pretty much we have this very close to your driller. The driller is drilling his well. He sees things going awry, immediately immediately goes to this panel and actuate what he needs to actuate as per the policy. So that's the system right there. So this will be that's the last piece of equipment that we'll be speaking about. Thank you everyone once again for listening up to this point. Thank you. As you go ahead to put in your comments, ask questions, like, and most especially subscribe and put on the notification button so that you can get notifications when as soon as we post new videos. Thank you once again. See you on the next topic. Bye for now.